In this video, we want to cover some basic concepts dealing with motion. The first one is position. So if we're talking about position, we're just talking about where something is in space. But in order to determine that, we need some sort of reference point. So you might have a reference like by the tree or by the gas station, something like that. Mathematically, we generally will use a reference point in the form of a Cartesian coordinate system, which is a fancy way of saying the old XY planes that you learned in algebra. So if I have an x-axis and a y-axis, this point right here, that's the origin, and that would be my reference point. So if I had some other point in space out here, I could say where that thing was located according to my origin of my coordinate system. And I could write it in terms of its x and y coordinates. Now if I have some point A here and I move to some additional point B, I've created a sense of motion. So what is motion? Motion is simply when you change your position. Now when we talk about positions, so let's say I've got some point A here and some point B, there are a couple of different concepts that we need to first cover. That is the idea of displacement and the idea of distance. So if I go from A to B in a straight path, from A to B in a straight path, that is called the displacement. So that's that straight line path. Now if we, instead of going on a straight line path, if we instead of going on a straight line path, we go on some sort of meandering path, like that, the displacement is still the same. It's still the distance between the starting point and the stopping point. So from here to here, that's going to be my displacement for the straight line path, and it'll be the displacement for this meandering path. So we can talk about the concept of distance, which is simply the length of the path. Again, we have the length of this path, the length of the straight line path, and then the length of this meandering path. So just to summarize, again, we have that displacement is the straight line distance from your starting point to your stopping point, and distance is the length of the path taken. So we can note also when we're talking about displacement that displacement has a direction. In other words, you can go from the starting point A to the final point B, and then you can go backwards. You could go from B to A, and in those situations, you're going in opposite directions. So where you start and where you stop, they determine your direction, and that's important for displacement. So the next concept that I want to cover is the difference between a vector and a scalar. A scalar is any quantity that can be characterized only by a magnitude. A vector, on the other hand, is a quantity that has a magnitude but also has a direction. So for example, if we're talking about a displacement vector, we could say we go 10 meters this way, and that would be 10 meters to the right. And then we could go 10 meters up. And we would have a complete displacement would be the distance from our starting point to our stopping point, and this would be our displacement along the entire path. The straight line distance from your starting point to your stopping point. Now here we actually have three different displacements. We have the first length of the path, which is described here, the second length of the path, which is described there, and then the total displacement there. So we can talk about the displacement from here to here, the displacement from there to there, and then the total displacement. And each of these paths have their own lengths and their own directions. So that is what you need to characterize a vector. You need a length or a magnitude, an amount, and you need a direction. Now, if I have a path, again, say from some point here, A, to some other point B, and I walk from A to B, and I can walk along the straight line path, or again, I can walk through some meandering curved path from A to B. Obviously, it's going to take some amount of time to walk those paths. This lets us define a couple of other concepts. Now, we can talk about the average speed, which is defined as the distance over the time. Now, the average speed is going to be the distance over the time. So I can calculate the average speed for this path, and I can calculate the average speed for that path. Just measure the distance and divide by the time it takes to walk from A to B. Measure the distance along my meandering path, divide it by the time it takes to walk along the meandering path, and in each of those two cases it would give me the average speed. Next we can talk about the average velocity. Now the average velocity, I'm going to write this up here because I'm running out of room. That's going to be the displacement divided by the time. So that's going to be the one that corresponds to the straight line path. So the average speed for the straight line path is also got the same amount as the average velocity, but the velocity also would have this direction, which we might say was over and up, or we might give some angle, but we would have to have the velocity give you the direction as well as the amount, because it's a vector, speed is a scalar. So that's the basic information that you'll need to conduct this week's experiment. Hopefully it will be something that helps you understand these concepts and get them down. So what you need to do next is go through the worksheet and do the experiment and then take the quiz. Good luck.